Swayam Prabha. Digital India. Educated India.
Now, let's start with the catalyst, right? So as I was mentioning that catalyst, as name suggests, catalyst is basically the accelerated PyTorch framework, right? And this was the development was started in 2016, but it has been now it is very mature and a lot of research and development pipeline using Catalyst. So it is necessary nowadays to understand this framework. So this is a framework for accelerated deep learning and R&D based on PyTorch. And what it helps is that it helps to write your code in very compact way, so that maintaining the huge pipeline of trainings will be seamless, and you can reproduce the trainings, the matrices, the parameters again and again from several runs. So now we will see the training loop. So if you are considering to explore your training module from different aspects, let's say I do not want only epochs to run, right? I want several batches to run, several loaders, maybe from different data sources. I want to load several loaders for each epoch for several stages. I want to have multi-stage pipeline in our training. So now we are getting into some advanced stage, but you understand that the training module is not just only one iteration of epoch. So there can be several loops that can engage the training pipeline for different exploration. So in the end of this exploration, let's say I want to save the best 3 modules out of that, right? So that is, so all these pipelines management will be abstracted into Catalyst in very simple custom running. So that is the flexibility of using this Catalyst that we will see. So supported features, as I was mentioning, you have universal train and inference loop. Universal train and inference loop, that is from the perspective of the target. So whether you are doing supervised learning, whether you are doing reinforcement learning, whether you are doing maybe regression, whether you are doing some classification like classic classification, which is also supervised, subset of supervised learning. But whatever you do, it will have one universal structure that you can follow, and also you will have the provisions for callbacks. So once you wrap the entire thing with this universal custom runner, which we will define in the next slide, there will be provisions for callbacks also. So you can also induce some customized things inside the universal training or inference loop. Configuration files for models, and that will help to have wide reproducibility. So if you maintain config file for your hyperparameters, you do not need to change anything inside your training model. You just change the config file for your training, and you just you just have completely another configuration for your training without much of the changes. And best practice for deep learning is using this kind of optimizers that you are seeing, like AdamW or SWA optimizer. So different choices that if you want to have flexibility in the choices of optimizer, or you want to have flexibility of choices inside the what are the metrics you want to see from the training, all these things you can actually abstract and define with the callbacks. Also, in addition, you will have the support for mixed precision that I was mentioning, that AP16 support, the distributed training support, slum support, and DALI loaders. So DALI loader, that you have seen that NVIDIA DALI loader, it is saying that you use DALI loader, but that support also is available inside this Catalyst framework. Okay? And this is also supported by several backend libraries like AMP, Apex. So these two libraries we talked about just now. And deep speed fair scale, deep speed from Microsoft, fair scale from Facebook, XLA, so for your Tensor course. So all these hardware backends will be supported from this framework. Okay? So this way it makes Catalyst a wide acceptable framework for accelerating your PyTorch training. Why we are talking about universal training loop? So inference loop essentially will help you to abstract inside your custom runner that I was talking about. Right? Now, runner is an abstraction that takes all the logic. So whether you are how many batches you want to handle, how many data, what kind of model you want to train, even some models if you want to import from the libraries, you can do that seamlessly. And everything, every matrix that are to be monitored, let's say accuracy, loss, precision, recall, F1 score. So any metrics you can think of from a universal training point of view, you can actually have complete abstraction into one wrapper called runner. And of course, there are a lot of more for wrapper, but we will see that eventually. So for PyTorch training, this is simple one batch training for several number of epochs you can see here. And in the end, we are printing the training loss. So as I was mentioning, there are few statistics you need to print, or maybe you need to give output into your loggers or profilers to be profiled in the end. But to print it every time, whatever you need to track. So if you have, let's say, multi-stage pipeline for a big model, and let's say several other models are also there to be taken into account into several stages, you can see how big this pipeline can be, right? And everything you can just customize into this custom runner, which is either it can be custom runner or superset of supervised runner and other runners also. So you just so this is the universal training wrap up. So basically, you need define the model, which model, criterion, optimizer, what are the train loader, valid loader, or how many number of epochs, what will be the log directory, if you want verbose or not. You just define this, and this will take care of entire loops of or for loop of your training. So this is just a simplified view of custom runner, but we will come into this in the demo session. Also, in the training stage, you can have logging, model checkpointing, and evaluation methods. Now, if you are a data scientist, for you, not only just model training is necessary. Once you write the model for the training, you need to log your different metrics, and for different metrics, what kind of performance you are getting. As I was showing from the tensor board, right, last time, what batch size or how the hyperparameters help, or combination of hyperparameters. So those were very small number of parameters that we are tracking in the tensor board. Now here, you can evaluate without writing any one piece more of code. So all these evaluation metrics that you can think of from any training pipeline point of view, it is already defined. You just need to use that, and you need to use that inside the callback. And also this model checkpointing will help you to evaluate these metrics, because you can have all these metrics stored in several checkpoints and evaluate based on those checkpoints. And also you can select what will be the best model outcome, and those model parameters you want to save it, you just say that inside this framework, and it will do all the things automatically. So let's see one such. So all this runner definition we'll see in this demo session. But as I was mentioning, the provision for callbacks will help you to customize your logic during. So universal training will give you the flexibility to define the universal loops. Now you want more, right? You want to customize your metrics evaluation. You want to log some of the performance metrics based on which you want to evaluate your model in the end. So all this customization you want to do, and that we can do using this callback. And once again, everything is PyTorch here. So once you are familiarized with the PyTorch syntaxes, usage, and maybe definitions, these are very easy to follow. So the same things will be followed, right? And it provides reusability. It will provide you to define your config file as well. So all these things are there. So we'll just go into the demo session to see what kind of flexibility we are going to get. So this is the tutorial provided by Sergey, who is actually initiator of this project, and now this is global community, completely open source. So you can follow. So all the links will be given to you, and you can follow the tutorial as you are seeing here. Now you have to install Catalyst for ML with all the machine learning components from Catalyst. So it will be in downloading all the necessary packages. It will install it, and let's see first classic computer vision classification. Okay, so the same things that we have described so far, like one classification training module. So basically, we are having the same torch and libraries that we have imported so far, and some Catalyst libraries we need. And also Catalyst database has several database support for, let's say, almost all the popular datasets are also available inside this Catalyst database. You can import them. So here we are not using Torch Vision for downloading the data, but you can use Torch Vision. So since Catalyst is being used, you can use Catalyst. So data loader. So basically, with all the transformers we have defined. So basically, once you have you want to define the model and optimizer for your device, just check that whether your runtime is GPU or not. So defining the loaders. So still now we are following the PyTorch. So this is simple PyTorch. Model optimizer, simple PyTorch definition. Then the custom runner definition. So this is the custom runner class, where the handle batch method is the most important batch method, which will define your entire training pattern. Okay. So handle batch has the unpacking of batch, running the model forward pass. So this model is essentially one simple model that we have defined with one layer here, right? Now we have then the train loader loaded, and we are doing the backward pass, then updating the optimizer with the gradients, and then zero grad initialization. So this is the simple training pipeline. Now we want to keep track of loss, accuracy, and so which are defined by this batch metrics update. So here we are seeing that only the metrics that we want to define, okay, and also these metrics will be actually computed and unpacked here, okay. So this batch size, for different batch sizes it will run, and in the end we are creating the abstraction. So this is the abstraction creation, and hit the run. So this is the runner.train with all these models, optimizer, loader, uh, which will be the log directory for your metrics that you have defined so far. Number of epochs 3, so it will take care of the loop automatically. Verb was true, so we are seeing all these outputs. And valid loader, so you want to validate. So with this valid matrix loss, and we want to minimize the valid matrix. We want to minimize the loss. So this is true. So you see, the entire pipelines for training and validation is actually defined in this simple training wrapper here with this runner abstraction. Okay. So you can see once we hit run, you are downloading the dataset here for number of epochs. So 3 epochs we have defined. You can see all these metrics that is computed automatically, and it is being logged inside your logs this path. Okay. And based models is being saved here. So based models is 3 out of 3. So basically the third model is the best model, and the accuracy is for your uh, loss is less. And so this is just the 3 epochs that it was shown. So this was a simple pipeline for definition, and more compaction you can do. So if you see this classification, so this is the same pipeline we are doing, but here the same training data, train loader, data loader, and valid loader we have defined. Model criterion and optimizer were defined with these parameters, and then we are using the supervised runner as the global or universal training model. Now, inside this training module, we are now defining some callbacks because we want to have the callback for accuracy. Okay, we want to we want to have callback for precision recall F1 score. So all these will be taken care of instantly and without any writing of single piece of code. So all these statistics will be actually stored. So this is the callback support that I was talking about. So instead of only running the module, which is the vanilla module running for this runner, okay, you can add the callbacks as you want to. Okay. So you want to have the confusion matrix callback. So I've added 3 callbacks here. Number of epochs, block directory, and whether this we are doing the validity. Now you can also support different validation metrics also. Okay, so micro averaging, micro averaging, and also the weighted averaging it supports F1 by these metrics. So this matrix is also supported, and you want to do let's say what was false, and also if you want to do the mixed precision training, AP16 equal to true, you can enable it. And since we have enabled it, you can see here that we are actually using Adam optimizer here, but uh, so so once we have actually imported the TL, so everything is imported here. You do not need to import the AMP explicitly, but since everything is imported, so you can use the mixed precision support automatically. Okay? And this will actually transfer the mixed precision support to the native Pytorch support. Okay, so this will not use the Apex NVIDIA Apex library, but it will use the native Pytorch mixed precision. So one more thing here. So as you are seeing that everything we are logging into this directory here for previous model as well, right? So in the logs directory with custom classification previously, and this is the classification, simple classification with these callbacks. And in the next, we want to do the multi-stage classification. So this is a bit advanced, and this will actually help you to understand the flexibility of using Catalyst in large scale training. Okay. So class customer runner, we are now defining it. So basically, we are defining the engine here. So AMP engine we are using. So again, this is just to use AMP library, and AMP engine will enable the TensorFlow execution. So get logger we want to have console, CSV, and TensorBoard available to these directories. And then we want to have multi-stage pipeline for the training. So now we want to have, let's say, two stages of training. Now, two stages means, let's say in first stage, we want to do the training and freeze the gradients. And then in the second stage, we will use another optimizer and we will tune those parameters and do that. And this is a very like normal way or typical way of training your deep neural networks with at least two stages, okay, to tune for your targeted data set, because whatever model you are using, that is not particularly, that will not be tuned for your particular data set, target data set. So this is a simple demonstration how you can use this multi-stage pipeline or manage multi-stage pipeline inside your Catalyst customer runner, right? And we are saying that each stage will have three epochs, and get the loaders, data loaders, get the model. So get model will define the model, and so basically here the model has two layers, two linear layers, and then in the training freeze stage, we are freezing the gradients where we are not updating the gradients, and here we are using the gradients to tune in the second stage. So basically these are the two stage, and you can see how seamlessly easy to define multi-stage training. Just two lines will help you to enable multi-stage training without, so three epochs we are using. So you can imagine like how this will be once you try to code it from vanilla PyTorch training, right? Now get criterion, you just do this. So basically we are defining uh, uh, cross entropy loss and optimizer for freezing stage. We are using Adam optimizer, and for non-freezing state we are using SGD optimizer. So this is also typical practice of using several optimizers into several stages to see what is the performance gain in the end, and for sure you will get better performance in get scheduler. Now this is to define how these optimizers will get scheduled inside your training pipeline. And now in get callbacks, we are defining all the callbacks for, let's say, criterion, accuracy, optimizer, precision, recall response score, configuration metrics, checkpoint callbacks. So checkpoint callback will help you to, in the end, uh, minimize the loss and save the best three choices. Let's say I want to save the best four choices, five choices, three choices, or maybe top performant model with this metrics, right? So all this you can do just defining these callbacks. That's it, as simple as that. And handle batch will actually do the training and defining the abstraction and hit the run, and that will do the job. So 1, 2, 3 for the first stage, multi-stage. We switch to the second stage, training 1, 2, 3 epochs, and you will see the metrics. All the metrics are computed automatically. The accuracy, precision, recall, F1 score. So everything is computed automatically, and they are being logged also depending on the path that we have defined, and the first three best performant model also is saved in this path. Okay? So that's that much of ease you will get using this framework to define the complex pipeline of multi-stage classification or even multi-stage training of your networks, right? Now, to see the logs, again, you can use TensorBoard here to get the profiles. So as you can see here, so for the multi-stage pipeline. So basically, this is the multi-stage classification that we have done for, okay, right? Yeah. And so you can see after first stage, the accuracy has hopped up, okay? And so this is the typical way of training your model. And you can see for all the basically for different parameters, all the parameters have been checkpointed here. You can see accuracy, F1 score, loss, your learning rate, momentum, precision, recall, support, so and also yeah. So this is you can just debug it and see what kind of analysis it can do. So this is the catalyst that we were talking. Also, in the slide, if you see, okay, let's go quickly to the demo of. So in this section, we have also given one link for you to refer the catalyst run in. So here we are seeing catalyst run in GPU. You can also refer another link for catalyst run in TPU. Okay, so this is just one or two lines of additional code that you need to do for your TPU, and you can change the runtime for TPU. And in the next week, we will see more of TPU execution. Um, but we will not discuss TPU execution right now, but you can refer to the link for how you can modify your training model for your TPU time. Okay? So to conclude, this catalyst is an accelerated framework for based on PyTorch, and it makes you to write your training loop very easily, and you can do some rapid experimentation, reproducibility, code-based reuse. Also, this is very important because once you have generated the config file, you can just reuse it for different trainings. So as our TA Vidya has written here, I don't know, this is the code from the initiator, write code with PyTorch, accelerate with Catalyst. Yeah. Thank you with these references, and we'll go to the question and answer session.